we want to find the coordinates of any stationary points on each of these curves. So the coordinates for the stationary points, we want to differentiate to get the gradient function and then make it equal to 0. Each of these we're going to have to use the quotient rule to differentiate because we've got one function divided by another function, one function divided by another function, one function divided by another function. So all of these we're using the quotient rule for. Right, in the first case then, my u is going to be the x squared, my v is going to be the 3 minus x. So u dash will be 2x, v dash will just be minus 1. Applying the quotient rule on this then. The quotient rule, remember, is u dash v minus v dash u over v squared. So in this case here, the u dash times v minus the v dash times u all over the v squared. Simplifying this then, just simplifying the numerator, we don't need to worry too much about the denominator. 2x times 3 is 6x, the 2x times the minus x is minus 2x squared. And then we have the minus minus, so a plus x squared. Collecting up the like terms then on the numerator, and we can then factorise the x out of the numerator here and here. So this is my gradient function in its simplest form. And for a stationary point, we want this gradient to equal 0, which is going to be the case if x times 6 minus x equals 0. So if either x is equal to 0, or if the 6 minus x is equal to 0, where x is 6. So these are the two x coordinates of my stationary points. To get the y coordinates, I need to substitute those into the original function. So if I substitute 0 into that original function, I get a y coordinate of 0. And if I substitute 6 into that original function, I get minus 12. So the two coordinates of my stationary points here are 0, 0 and 6 minus 12. Next question. Draw a line to keep. Right, so in this case, my u is going to be the e to the power 4x, that's on the numerator there, and my v is going to be the 2x minus 1. Differentiating the e to the power 4x, I get 4e to the power 4x, because the exponential will differentiate to be the exponential, and I have to times by 4 because of the derivative of the 4x. Now differentiating the 2x minus 1, I'll get 2. And now to apply the quotient rule, which is u dash times v minus v dash times u, all over v squared. We can simplify this now then. The 4e to the power 4x times 2 is going to be 8 x e to the 4x. 4e to the power 4x times minus 1. And then we've got the minus 2e to the power 4x on the end there. Leave the denominator as it is, that's fine. Collecting up these like terms on the numerator. And then I can factorise this e to the power 4x, and I can factorise a 2 outside on the numerator. So just do a quick check. This times this is this. And this times this is this. And for the stationary point, we want this gradient function to equal 0. Let's create a little tiny bit more space. Right, this is going to equal 0 if 2e to the power 4x times 4x minus 3 is equal to 0. This can never equal 0 because it's the exponential. And remember, the exponential graph looks like this. It never passes through the x-axis. So the only solution can come from where this is equal to 0, which is where x is equal to 3/4. To get the y-coordinate, I'm going to substitute 3/4 in up here, instead of the x here and here. So e to the power of 4 times 3/4 is just e cubed. And then 2 times 3/4 is 3/2, or 1.5. Minus 1 is a half. The e cubed divided by a half is 2e cubed. And that's the coordinate of my stationary point. Last example. Again, this is a quotient with the x squared minus 3 being my numerator, so that's my u function, and the x plus 2, that's on the denominator, so that's my v function. So u dash is going to be 2x, v dash is just going to be 1. Applying the quotient rule, we've got u dash times v minus v dash times u all over the v squared. Expanding the brackets on the numerator, we get 2x squared plus 4x minus x squared plus 3. Just be careful with the minus and the minus there. Collecting up the like terms, the 2x squared minus the x squared is just x squared. And we can factorise that numerator a little bit more. It's going to be x plus 3 times x plus 1. This is just this been factorised. And we're looking to find when does this equal 0 for our stationary point. Well, it's going to equal 0 if x plus 3 times x plus 1 is equal to 0, which is going to be if x is equal to minus 3 or if x is equal to minus 1. And if we substitute both of those back into this original function, that will tell me the y coordinates. So if I substitute minus 3 into that original equation, I get minus 6. If I substitute minus 1 into that original equation, I get minus 2. So these are the coordinates of my stationary points that are on that curve.